Good morning to you all. A warm welcome to the technology stage here at GreenTech 2023. My name is Luijten, and today I have the honor of hosting this esteemed panel of specialists who will enlighten us around the topic how to reduce energy inside your greenhouse. So, as the energy prices soared high last winter, the importance of energy conserving techniques has become increasingly high. And these experts will take us on a journey for energy-saving techniques. And also on a journey to LED lights. So, let me introduce you to our first speaker, Brelsford. Craig is plant specialist and working at Valoya, part of GreenTech lighting solutions. He will explain more about the game-changing potential of UVA radiation in plant compound production and tomato cultivation. The floor is yours.
Thank you. Okay, hi everyone. Very nice to be here. So the title of my presentation today is Illuminating Success with LEDs, UVA plant compounds and energy usage. So a little bit about Valoya. So we provide lighting solutions for crop science, greenhouses, vertical farming, and medicinal plants. We're based in Finland, and we were founded in 2009. And we're really driven by research and the results, and we take that forward to our customers. So we've now done over 644 experiments, and that includes over 300 species of plants/varieties which we've tested. Now, to start off with, I'll show first here the different wavelengths of light which we have, and we'll go through what we mean by UVA radiation. So, on the bottom of the figure, you can see the different wavelengths of solar radiation, from 400 to 700 nanometers. This is what we have in the visible region, so you can see it with the human eye. And we also call this PAR, or PAR, and that stands for photosynthetically active radiation. So these are the wavelengths that plants use for photosynthesis, so they can drive forward to make energy. From 700 to 800 nanometers, this is far red, and we at Valoya, we also use that in our LEDs. And then below 400 nanometers, this is where we have UV radiation, and this is what I'm going to focus on here today in this presentation. So we can break that up even further into UVC, UVB, and UVA. And UVA in particular, this is from 315 to 400 nanometers. So these are now the longer wavelengths of UV. And what's well known about UVA is that firstly, you can get secondary metabolites for your plants, and then you can also get compact growth. And so now this is what I'm going to talk about in the second part of this presentation. It's the effects of UVA on plant compounds as well as compact growth. So as I mentioned, we're really driven by research, and we've been collaborating with Hoogendoorn University in Germany doing trials. And they've done a trial looking at cannabis. And in this trial, they had 3 different treatments. So the first treatment was with high-pressure sodium, or HPS. The second treatment was with broad-spectrum LEDs. And then in this third treatment, they had broad-spectrum LEDs again, but with UVA inside of it. And then one of the things that they measured was the concentration of CBG. And this compound is of medicinal interest because it helps with sleep, appetite, and pain relief. And so here we have the results. So those 3 different treatments I mentioned are on the bottom on the x-axis. So the HPS, the LED, and the LED with UVA. And then we have the concentration of CBG on the y-axis, on the vertical side. And so what we see is that firstly, you get an increase in the CBG just by switching to LED from HPS. And then secondly, you get even more of an increase in the LED spectrum, which contained UVA. And actually, this increase is a 2.4 times increase. So this is a very large relative increase. And I've shown these results here just to demonstrate that how UVA can increase your secondary metabolites. So it just doesn't go for CBG, but also it's well known the same as for flavonoids as well. So these help with things such as color, flavor, scent, taste, things like that. And so at Valoya, we've taken this information and then we've now optimized a spectrum called Solray 385. And here I'm just going to highlight one of the things about it. So at 385 nanometers in the UVA range, we have a small peak here. And so this is completely safe, complies with EU standards. It's the equivalent amount of UVA you would get, say, in Finland in February. And we know it's an important signal for plants. And so now I'm going to show a bit more about that, in particular about the plant compact growth response to this UVA signal in Solray 385. So we've also been doing trials in Göing, Sweden, with growers. And these were done with tomato seedlings. And one of the things that we see there is that when you have this LED spectrum, the Solray 385, which contains UVA, the plants have a compact growth form which is 3 centimeters shorter. Now in this case, this is really what this grower wants. And this is because once you take those tomato seedlings to transport, you want seedlings which are tough, durable, they're not going to break once they go out to transport from the greenhouse. And we see a similar thing with cannabis. So this was another trial done at Hohenheim University. And what they showed is that when they compared different spectra the plants were exposed to, when using this Solray 385, not only do you get a high yield, but you get a compact growth form. And so for cannabis, this is really crucial because you can fit more plants within a given area. So overall, you get a higher yield per the amount of space. And you can see here in the picture illustrating the plants which were grown with Solray 385 are indeed the compact ones. And so this is part of a wider discussion on energy usage. And so we also have some tips here in the context of this. So firstly, this is a well-known one. Just by switching to LEDs from HPS, on average, you save 44% electricity. The second advantage is that you get to tailor your spectrum. So you can start then adjusting for the best light recipe for your plant to get the growth that you want. And then the third tip here is get to know your DLI values. So DLI stands for daily light integral. And that's essentially the amount of light in a day which your plant needs. And my suggestion would be, if you're not familiar with these, then companies such as Valoya, we provide them and we guide you through it. And that's something which means you don't use too much light, use just the amount necessary for your plant. Another important point is obviously checking the efficacies of your LEDs, so how efficient they are. However, I'd say that's not the be-all and end-all. Wavelengths such as UVA, which we've discussed already, and far red, there's thousands of research articles showing how important these are for plant responses. And you can get big increases in yield and the quality in your plants. So what's important is to also check the amount of yield per watt you're getting per your investment. And we would aim to maximize that because ultimately it's the profit that you want per watt. So just to go again over what we've discussed today, we've defined the different wavelengths of UVA. We've gone through the benefits of including it. So that includes secondary metabolites and compact growth. And then lastly, tips for energy usage. So that includes getting to know your DLI values, switching from HPS to LEDs, and then lastly, checking the quality or yield you get per watt invested. Thank you very much, and I look forward to hearing from the other speakers here as well. Thanks.
Thank you, Greg. What a wonderful presentation. If you have questions, you can ask your questions during the Q&A after all the presentations. So let me allow you to introduce you to Paul Arkesteijn. Paul is a researcher at Ludvig Svensson and the world leader for textile-based solutions for energy savings. And Paul will take us on a journey through 3 new innovations for energy savings in greenhouses. A warm welcome to Paul.
Thank you. Thanks, Angela. My name is Paul Arkesteijn, working as a researcher, practical researcher at Ludvig Svensson for more than a decade now. and I'm involved in practical measurements and gathering facts of our products in the greenhouse. Ludvig Svensson is manufacturer of climate screens. By help of climate screens you can save energy, control the light, shading, and also block the light for artificial light and short day treatment. This morning I'm going to dive in three new innovations we are presenting proudly on this GreenTech show, and it all has to do to reduce energy in the greenhouse. The first one we call Energy Perfect, and it is how can I save even more energy than we already do now today with our existing products. It's a concept of two screens, a transparent screen that saves energy, we name it the Lux family, well known in the market, and a new innovation, we're reintroducing it again, is a flame retardant full aluminium screen. And the combination of these two makes it possible to save more energy. On the right picture, it's made in improvement center in Brelsford. We already trialed the concept of these two screens. We see the full aluminium screen together with the transparent screen. By using both screens at night, you save the optimum, and then during after sunrise and before sunset you open the aluminium screen because it takes away the light, and you continue saving with a high transparent Luxus energy screen. Besides energy saving, the full aluminium screen also has benefits for the crop. It blocks the outgoing long wave radiation, so you get a higher plant temperature. Proven in this trial, also in this and visualized in the graph, that the net radiation is measured. That's the incoming radiation from the sun and the outgoing radiation from the canopy. And that's the yellow line. The black line is the aluminium screen that is closing. And you see it's midnight, May 9th. The net radiation is a little bit below zero, about -8, -9 watt a square meter. So there is radiation going out of the crop, so a lower crop temperature. On the moment the screen is closed, you see a rise in the net radiation. It goes almost to zero, so then it's balancing. And at the other side in the morning, screen opens again, you see the drop again, showing the benefit of the aluminium screen. To control both screens in an optimal way, we also provide advice to optimize it right from day one. And of course, important, the new screen is also flame retardant. It's a need in the Netherlands and Belgium and also in other countries nowadays for insurance companies to have it flame retardant, that the screen does not transport an eventually fire in the greenhouse. The screen already has been proven, like said in the Delphi Improvement Center, in a trial with paprika. The goal there is to use 10 cubic meter gas a year, very ambitious, and this solution of the double screen Energy Perfect is part of the reason that we are succeeding in that. The full aluminium screen has also a second function. The name is Obscura 9970 FRA, aluminium. It can be used as a light pollution screen. So when it's artificial light in the greenhouse, LEDs or Sonti, the light needs to be inside, remain inside the greenhouse to prevent pollution of the environment outside, and this screen can also be used for that. And especially for LED lighted crops that bring in less warmth compared to the Sonti lamps, the extra insulation and the properties of aluminium is a good match. Also, this is trialed already last winter. You see here a tomato crop with the full aluminium screen and also and it's lighted, LEDs are now off, with the Luxus. Like said, tomato lighted trial Delphi Improvement Center. Last year we used the standard Obscura, now this year the aluminium, to show the extra savings, and it goes really well. The second introduction, somewhere else in the world, it's about semi-closed greenhouses in hot areas. So these are greenhouses not using the ventilation, but are controlled in the greenhouse by expensive electric controlled cooling equipment. To lower the cost of cooling, we introduced Power Perfect cooling. The concept of Power Perfect is a double screen to control the sunlight. And in this case, it's on the right picture here, also the sunlight is partly reflected by the upper screen because of its high white upper surface. So by the knowledge we have, also raised by the Wageningen University, the tomato plant or vegetable canopy needs light, a lot of light, but there is a maximum. So using this knowledge you start to shade. Power Perfect takes care of a very even distribution of the light, horizontally and vertically. And the too much light we are reflecting. So it's not entering the greenhouse, so also the energy is not entering. So that helps to reduce the cost for the cooling equipment. This is already proven in this case in Australia greenhouse, very short explaining. Outside temperature poops up to 35 Celsius. The green line is the inside temperature. In the morning it's the same. Then the first screen is closed. You see a drop in inside temperature as an addition to the cooling equipment. And here it happens again with the second screen partly being closed. In the afternoon you see the drop again the other way around. So, summarized, controlling light and temperature in a good way, sunlight, in a semi-closed greenhouse in a hot area, Australia, parts of North America, Middle East, by not allowing the sunlight to enter the greenhouse, Power Perfect cooling. And the third innovation we bring is a monitor, a software package that can show you, it's advising to optimize the screen use. As an example, give the answer how much can I save extra by help of my screens by closing it for 10 minutes longer as an example. It's a dashboard with Svensson knowledge, but it is provided on letsgrow.com, and it gives you a live and historical insight in the real energy savings of the screen. So it's for that greenhouse, for that screen type, and also the corresponding money savings the screen is making. It also shows the opportunity that you can save more, so it makes clear the missed energy savings, actual. And based on that, it's optimized and advised to open or close the screen more, longer or earlier. Shortly to zoom in, how does this Svensson energy monitor looks like? On the left top, actual screen position. And in this example, the last night it was saving $10,000 and we missed $100. Right top is the energy savings, real time in cubic meter gas. Underneath, it's based on measurements in the climate, from the climate computer, the warmth output of the heating tubes. And left is the advice. We see here the screen position, it's closed, and the red one is the advice. So it's closed at midnight, but why not close it before? It was cold outside, circumstances were well, close it earlier. A report of the savings over the week. In a graphical presentation, these are the savings per day, green lines, cubic meter gas, multiplied by 1,000. And the red one, that could be better. And underneath, quite impressive, for a crop starting in December, going on till May, you see this single layer Luxus screen saved more than €200,000 in this greenhouse, in this case in Canada. And you could do better, about 10% more. So that is the lesson this monitor gives him. Yeah? That was my presentation. 3 topics on how to save energy.
Thank you, Paul.
Welcome.
I think everyone needs an energy monitor now. Last but not least, I would like to introduce you to Anthanasios Sapounas. He is researcher representing TNO. And TNO is an independent research organization and a driving force behind innovation. He will provide information from the TNO and Hortivation project, which will share the KPIs on evaluating different dehumidification systems. The floor is yours.
Thank you, Angela. I'm Anthanasios Sapounas. I'm a researcher at TNO. TNO is the Netherlands Organization for Applied Scientific Research. I'm working in TNO for more than 5 years now. And today I have the opportunity to present to you a project that we are running related to development of a method based on key performance indicators in order to evaluate dehumidification systems for greenhouses. So humidity is really important in greenhouses. It's very well known because strongly influence transpiration and stomata behavior. For transpiration is the second most important factor actually after radiation, and has a key role in transpiration in stomata, and obviously in photosynthesis. So humidity is really important. Humidity control now is mainly the most challenging control of the greenhouse climate, most challenging control parameter. We always try to keep the humidity level in a certain range. This range is not constant, can vary according to the development stage of the crop, can vary according to the crop itself, and other factors like risk diseases. And usually we control the ventilation by the humidity either by ventilation, natural or forced, or by condensation, by applying heating, and or by using hygroscopic materials. These are the physical process. Although there are many systems in the market, commercial systems, that they use this physical process, of course, but in different ways. The question now is why key performance indicators, which is the necessity, I would say. For someone who is not familiar with the term KPI, key performance indicators, it started to be used 15 years ago mainly to evaluate the performance of big organizations, governmental organizations and big companies. And always these KPI methods are related to economic output, to management matters, and to targets set in advance. So a system, a method to evaluate how an organization, a company, whatever behaves, performs according to the targets set in advance was necessary. However, recently, the last 10 years, these KPIs are used more and more also to physical entities, to engineering systems, to any sector, I would say. For example, now we use KPI methods to evaluate the energy performance of buildings. A few years ago, we were happy if we could have a kind of indication about which is the energy consumption per square meter for a building, commercial building or a greenhouse. Now, by using a system level KPI approach, we can go deeper and we can focus on the performance of a certain system, on the performance of the subsystem of a system, or even on the performance of equipment of the system that we want to focus on. Also, recently, the KPIs are used, a system of KPIs was developed in the frame of the SCOPE project, which targeted to develop a method for evaluating thermal energy consumption in the agri-food sector. More than 104 KPIs were defined, and these were used to evaluate the thermal energy performance in the dairy sector, in the cereal drying, fruit and vegetables transformation, and meat processing. So we see that the methods is used more and more. Going back to the greenhouses, we have many commercial systems, but now we don't have a method or a tool to compare these systems. I mean the dehumidification systems. We cannot compare them only based on the information provided by the manufacturers, although I'm not saying that this information are not correct. It's not a matter if it's correct or not, but if are enough to make decisions in advance when we want to choose for a system. In this case, a dehumidification system. The systems are different in terms of operating principle, capacity, specific energy consumption, treatment, indoor, outdoor, exist of distribution system or not, heat recovery, and location, installation, and maintenance. These are the most important. So what we have done is that we try to summarize all the KPIs related to commercial systems, but also systems that were found in the literature or were tested in by research institutes or universities. We try to define KPIs in order to be able to provide information about how a system performs under different conditions, because now what we have from manufacturers about the humidification systems is that this is the amount of water can be recovered per kilowatt hour under these conditions, but these conditions are not constant in a greenhouse. We want to consider the whole cultivation period. We want to consider the homogeneity of the greenhouse environment, the potential energy saving. Now we read that by using a dehumidifier we can save energy up to 50%, but this is just a value. Can we rely on this value for a proper choice? And of course we should consider also the maintenance, the service, etc. So as I said, we summarize all the KPIs that are describing in a proper way the humidification systems. And I want to say that it's not only dehumidifiers, but systems can be used in a greenhouse for dehumidification purposes. And we divide this, we group these KPIs in these 10 groups, and in 3 different levels. We have the system level, which means that we focus on the system which is used. We have the process level, we focus on the process, on the physical process of the system. And we have what we call resource level, is we focus on KPIs that are able to describe in a proper way how we use resources, energy, that's why we're here now, energy, mainly in greenhouses. So the next step goes to start the documentation. In KPI methods, documentation is really important because a method should be adopted by the sector. So what is really important is the participation of the companies and documentation, because we should have a proper description of these KPIs. We should have a definition, clear definition, and a proper description. And this is really important. And of course, a KPI should have a value. A value can be a quantity, can be also a string, quality, but a value can be a group of values like curves, for example, figures, etc. And we must always have a reference about the value that we use. A reference can be the manufacturer, it can be a simulation model, can be a measurement. So now we are in this stage to develop these templates. We call it simply KPI templates. And finally, to get the overall KPI evaluation of a system based on KPIs, single KPIs for a system. The data will be stored in a database, of course, and in order to be used as a decision support tool to evaluate different systems. Which are the next steps? To finalize the definition of the KPIs that we are going to use to design the templates. We have seen that more or less. Most important is to use the data from commercial greenhouses to calculate, to use the KPIs that we defined based on this real data, and after reconsider all the KPI methodology that we followed until now. The biggest challenge for us is, from one side, we need a system, a method that can properly describe the commercial systems used for dehumidification. From the other side, the method should be simple enough in order to be adopted, objective and simple enough to be adopted by the industry. Thank you so much, and I'm willing to answer any question you might have.
Thank you so much as well. What an inspiring story about the KPIs and the importance of these. Before we go to the questions from the public, I have some questions as well. So, Craig, first of all, in terms of future energy usage, how do LED lights impact the overall energy consumption?
Yeah, really good question. So I think there's a few points maybe related to this. One is the efficacy of LEDs has been increasing all the time, and I don't think there's anything to suggest that that's going to stop in the future. So I think efficacy will continue to increase. The second part is using sensor systems and integrate with sensor systems. This is also something that's developing all the time, so making sure you only use your lights when they're needed.
Very important.
Yeah, and then maybe last one also is it's related to the sensor systems a bit, but it's also the use of artificial intelligence. So a lot of people are developing algorithms now which do a lot of this work and integrating different environmental variables along with your light as well.
We also saw it in the presentation of Paul.
Yeah.
Wonderful, wonderful. And Paul, I saw the new aluminum energy screens. Are they also address the issue of light pollution?
Yes, good question. Yes, the first goal was saving energy, but then on the way, extra energy. We also made it light tight, so meaning less than 1% light transmission. So then it's also applicable for lighted crops. And what we learned the last 1-2 years, visiting the trials running, that with full LED trials, there is an effect on the crop. The microclimate is different from, you can say, heated Santi lamps. And aluminium screen is part, or was the answer to that, because, like explained, it blocks the outgoing radiation, creating the better microclimate. Yes.
That's wonderful and very important. Maybe we can answer some questions from the public now. So, are there any questions over here? Yes. Egon.
I'm Egon Janssen, TNO. I have a question for Paul. Nice dashboard you have with the energy monitor. I was wondering, do you also have information on the reduction in the crop production, or only the energy?
Very good question, Egon. Okay. A very good question. Answer is no. This is purely focused on energy saving. On the moment you are including the crop performance, it will be a very extended model. Maybe in the future, maybe in cooperation with other companies in that, but this is purely focused on energy saving, yeah.
Wonderful. Are there any other questions? Yeah, over there. Please introduce yourself as well.
Baran Drakolu from Van der Hoeve. Is there a difference between the existing Power Perfect system and Power Perfect cooling?
Good one. PowerPerfect is focused on shading crops. Netherlands, America, warm climate, or normal climates. So it's about the plant needs shade, and we use that, for instance, Phalaenopsis or potted plants or cut flowers. We need that we can vary the shade with the two screens. In this case, it's a solution based on PowerPerfect, so we have even light distribution, but then we focus on semi-closed greenhouses to get, like I explained, to reflect energy that's not needed inside the greenhouse. So we have the benefits of PowerPerfect. In addition, we save energy. Okay.
That's great. Any other questions? Don't be afraid to ask. They are here now. Yes. Also a question from TNO.
Yeah, thank you, Angela.
You're welcome.
Yeah, about LEDs. Maybe it's a very generic one, but you know, if we all have advantages of LEDs, why do we use them that much? Is it pricing?
So
Any other arguments?
for using LEDs over, say, HPS, is that?
Correct.
Yeah. Yeah, so many benefits to using. So I mentioned reduced energy savings with electricity, for instance, when you make the switch. The second one is you get a longer lifetime with LEDs as well, so you're going to replace them less often. You have dimmability in them. You have tailored spectrum, so you can really get completely different growth forms, which you wouldn't get, say, with HPS. Initial pricing can be a bit higher, but over the lifespan, it works out a lot better because of all the other advantages that I mentioned. Yeah, please.
Yeah, but I'm not here anymore. You hear me? Yeah.
Yes,
Yeah.
I'm here.
No, I wanted to follow up.
Yeah.
But growers that use now HPS lighting will not switch to LEDs that quickly.
Yeah.
I mean, they wait until the HPS lights are, I don't know, out of order or something like that.
Yeah.
So is that the main reason why? Okay, because of the advantage of LEDs, it's not taking that fast?
Possibly. But I also appreciate, for growers, it's not just your light, and for many growers, they've got to know a system. So, for instance, there are many other things you have to adjust. So your heating might have to change a bit or something to adjust for that. But I think the trend is more and more people are switching. And as I mentioned, the efficacy of LEDs is getting better and better. So they're just going to continue to get cheaper to run. So I think in the end, more and more people are just going to keep switching and switching.
Thank you. Thank you. Maybe one last question from the public. No? Anything clear? Then I have a question also for Anthanasios and Paul together. Is there a crossover between dehumidification systems and screens?
Yeah. Because a screen saves energy when you fully close it.
Yes.
When you work with double screens, that's kind of standard nowadays, also especially since the energy crisis and also with LED. It might come that the evaporation is taking place is a lot. The screen is transporting humid, but till a certain limit. So then you can choose, okay, I make a screen gap with all the disadvantages as a follow-up. You get an uneven climate, full of cold air, local diseases in plants and so on, and you save less energy. When you have a dehumidification system, you save energy by fully closing the screens or the two screens, and that is possible when you take out the humidity. So there is a really big crossover, and when you talk about energy saving, I think it has to do always to do with screens.
Wonderful.
As I said.
Do you want to add something?
Yes, now more and more systems, the humidification systems used in order to bring the air from above the screen to the greenhouse, because the air above the screen is much drier. So we see many systems in the market that they are able to do that. Of course, there's a question how efficient they are, how much air they can bring, which is the homogeneity of the environment. So that's why the approach of having indexes or indicators to evaluate these systems is important.
Yes.
but definitely there is a cross, let's say, interest with screens.
Are you also developing KPI systems for other systems at the moment, or maybe you can tell something about that?
This is the intention of the TNO and cultivation, because there are three reasons for that. The first is that we need tools to compare systems. Now we don't have such a tools. It's so simple. We must have tools to compare, to evaluate our decisions.
Yes.
The second reason is that now more and more we have the ability to measure things. So a KPI method is not only to evaluate, to make a good decision, let's say in advance when I build a project, when I design a project, but I'm able also to monitor.
Good.
I have the data, I can measure, I can monitor, I can develop my product, I can offer a better solution. And the third reason, for me maybe the most important, is that the Dutch sector always try to develop methods to keep the leading position, to improve the products, to provide better services, to build confidence with the customers, because we provide products all
And
over
then
the
we need
world.
an objective system. So.
Yeah, correct.
Thank you so much. Thank you all for your attention, and I hope you learned a lot of how to save energy inside your greenhouse. I will thank all speakers of today, and if you want to ask them something, they are walking around. So, thank you all.